Hi everyone, Miss James here. Today in class we developed the kinematic equations based on data, and boy was that a lesson. Now I want you to listen to this video where we're going to do a similar kind of thing, but now just based on the definitions. Alright, so what are the kinematic equations? The kinematic equations are here. We developed this from a velocity time graph. We developed this from a distance time graph. Now we're not going to use the graphs. We're just going to use definitions of velocity and of average velocity and of acceleration. Okay, so first I'm going to develop this equation. Let's get started. Okay, here's the definition of acceleration. The acceleration is the velocity, the change in velocity over time, which is basically the final minus the initial velocity times time. So I'm going to multiply both sides here by t, and I'm going to wind up with at equals v minus v0. Now I want v by itself, so I'm going to add v0 to each side. And I'm going to wind up with our final equation, which is v equals v0 plus at. Please forgive my horrible handwriting here. And that's the same equation as the equation back here, one of our kinematics, v equals v0 plus at. Next, let's try to identify or prove that the distance one. So that one starts with average velocity. Now, average velocity is the distance over the time, and another way of describing it is v plus v0 over 2. I'm going to solve this one for v. So the first thing I have to do is get rid of the 2. So I'm going to first multiply by 2, both sides. So I'm going to wind up with d times 2 over t equals v plus v0. And now to get v by itself, I'm going to subtract v0 from each side. And I wind up then with v equals v0. Oh, sorry. Let's do 2d over t minus v0. But I also know that v equals v0 plus at. Right? That was the kinematic equation I just came up with from the last slide. V equals v0 plus at. So now I can equate these two and solve for d. Well, first I'm going to add v0 to each side. Then I'm going to wind up with 2d over t equals, I've got the v0 plus another v0, that's 2v0 plus at. Now remember, I want to get d by itself, so I'm going to multiply both terms here by t. That gives me 2d equals 2v0t, 2v0t plus a t and another t, so that's t squared. Oh, that's not a very good t squared. Let's try that one again. Okay. Now to get d by itself, I'm going to divide both sides by 2. And I will wind up with d equals 2v0t divided by 2 is v0t plus at squared divided by 2 is 1/2 a t squared. And there you go. That's both of the kinematic equations developed based on the definition. Thanks. Bye.